Okay, so today we're going to do the inverse functions. Exponentials and logarithmic functions are inverses of each other, okay? We talked about inverses before, the rules still apply. So if you want to find the inverse algebraically, then you interchange x and y, and then you solve for y. I'm going to pause here. I want you guys using these instructions right here. These are the directions on how to find the inverse. I want you guys to find the inverse of problem number 1. Okay, good job, guys. I walked around and most of you guys had it. So this is y equals 2x plus 1. To find the inverse, we have to interchange x and y. So we'll rewrite this as x equals 2y plus 1. And then we're going to go ahead and solve for y. Subtract 1. So I get x minus 1 equals 2y. And then we're going to divide everything by 2. So that means the inverse is x over 2 minus a half. Okay. Now, guys, it says find the inverse function g of x. So I'm going to call it g of x. Instead of using this symbol for the inverse, we'll call it what they wanted us to. So this is the inverse. Okay? All right. Now, number 2, it says use the definition of inverse functions to prove that this and the g of x that we just found are actually inverses of each other. We need to prove it. So let's go back to the definition. It says, remember that f and g are inverses of each other if and only if you do the composition going both ways, you'll get x. Meaning if I put g of x inside of f of x, you get x. You put f of x inside of g of x, you get x. I'm going to pause here and I'm going to let you guys try it. Okay, so number 2, we're proving that these are indeed inverses of each other. So I'm going to write f of x here. The equation for f of x is 2x plus 1. And inside of the parentheses, I'm going to put in the function g. So I'm going to put x divided by 2 minus a half. I'm putting g inside of the function f. So let's see what happens when I do that. I'm going to distribute this, so I get 2x over 2 minus 2 over 2 plus 1. That cancels out. 2 divided by 2 is just 1 plus 1. Minus 1 plus 1 cancels out. I'm left with x. Because I was left with x, I'm halfway there. We have some hope. Let's do g and put f inside of it. So let's look at this equation here. I'm going to write down that equation. Okay, I'm going to write down g of x equation. It's x over 2 minus 1 half. Now, instead of putting an x here, I'm going to plug in this f equation. I'm going to put that in right here. That's 2x plus 1. Okay, so I'm going to break apart this fraction. I can rewrite this as 2x over 2 plus 1 over 2. Okay, you can split this up. Minus 1 half. Well, those cancel out. The 2's cancel out. I'm left with x. So I'm left with x on both of them. That means they are inverses of each other. Okay, so that's how you use that definition of an inverse. Now, number 3 just wants you to graph both of those lines. So you have the f of x equation. Go ahead and graph it over here. And then you have the g of x equation, which you're also going to graph over here. And it's asking, what is the line of symmetry between the graphs? Okay, while you guys are working, I'm going to go ahead and graph it on here as well. Okay, this is the line for f of x. The line for g of x. I'm gonna start at -1/2 and go up 1/2. Up 1/2. This is the line for g of x. So your graph should look exactly like mine. Okay, so it says, what is the line of symmetry? The line of symmetry, I'm going to draw it for you, is right here across the diagonal. Each point on the lines are the same distance to this red line that I just drew, the axis of symmetry. Meaning this point is the same distance from that point. Oh, they're the same distance. It's like they're looking in the mirror at each other. That is the axis of symmetry. They are symmetrical about that line. Okay? That line, oops, how do I undo that? Okay, the axis of symmetry is the line y equals x. So what is the line of symmetry between the graphs? The answer is y equals x, this diagonal line. Inverses always reflect across this diagonal line y equals x. So guys, this g of x graph, the equation here is exponential. So I'm going to put 2 to the 0. I'll just do that. Actually, I'll put 10 to the 0. That's more accurate. This point is 10 to the 0. This point is 10 to the 1. So guys, what do you think the equation is? Ten to the power of x. This point right here is 10 to the power of 0, which is just 1. This point right here is 10 to the power of 1, which is just 10. So that is the equation of this line here. The inverse of 10 to the power of x is log base 10 of x. These are inverses of each other. Okay? Now, similarly, if I have a graph or an equation that had 2 to the power of x, the inverse would be log base 2x. Okay? And if I had e to the power of x, the inverse of that would be log base e of x. Is that okay, guys? Now, when it's base 10 right here, what is that called? Do you guys remember the name of this log?
Common log.
Yes, this is called the common log. And you do not have to write this 10 here. It's not wrong if you put it, but whenever it's blank, just know the base is 10. Okay? All right, another thing that I want to point out here. We will not write this. Instead of writing log with the base e, we will write this as ln x. Okay? So that is the next part of your paper. Whenever you see log base e, you're going to write ln. This stands for natural log. Natural log is when you have a base of e. Natural log. So when you have log base e of x, you will write it as ln x. So let's look at some examples. Guys, number 5, we have a little error right here. Please write this as f of x equals 5 to the power of x. Okay, so we're going to write the inverse of each one. Guys, based off of what I just told you here, right? If I have 10 to the power of x, this is the inverse. If I have 2 to the power of x, this is the inverse with base 2. What do you think the inverse of 5 to the power of x is?
Log 5.
Yes. So we're going to write it as g of x, which is the inverse, is log base 5 of x. That is the inverse. Now, if I have log base 4, what do you think the inverse would be? Yep, 4 to the x. That would be the inverse. Exponentials and logs are inverses of each other. Just like multiplication and division are inverses of each other. Addition and subtraction, they're inverses of each other. They cancel each other out, okay? This one, what is the inverse? Yep, e to the power of x. And I'll write g of x in front. These are inverses of each other. They undo each other, okay? If I have 20 and I multiply it by 5, I get 100, right? But then if I divide it by 5, I get back to the original answer. Multiplication and division, they undo each other, okay? Just like exponentials and logs, they undo each other. They cancel each other out. Okay. Let's look at these. We're going to prove that they're inverses of each other by composition. Again, this is a typo right here. Please write this as f of x equals 5 to the power of x. Now, guys, what did y'all just tell me the inverse was?
Log base 5.
Yes, log base 5x. Okay, so remember, compositions means we're going to put one function inside of another to prove that they're inverses, okay? So I'm going to put g inside of f. So the way that will look is I'm going to go ahead and write f. But instead of putting an x there, I'm going to erase it and put g inside of there. So it will be log base 5 of x. And that's it. We're putting one inside of the other. And what you guys are going to see, because they are inverses, inverses cancel each other out. So 5 to the power of a log base 5, they cancel each other out, and you're just left with x. That's why it says equals x. And I'll do this next one. Now we're going to put f inside of g. So I'm going to write g nice and big right here. But instead of putting an x here, I'm going to erase this and put f inside of it. Okay. Log base 5 and an exponential 5 to the power of x. These cancel. Logs and exponentials cancel out, okay? So I'm left with just x. I'm going to have you guys do the next two. Whenever you have a exponential, like 3 to the power of something, whenever you have an exponential with a log, it's going to cancel, okay? Whenever you have a log to an exponential with an exponential, it's going to cancel. The whole thing is going to cancel. It'll just be left with whatever on the inside of those parentheses. Okay? They always cancel. So I'm going to let you guys do the other two. So guys, this is just reviewing what we just talked about. When you have log with the base, same as the exponentials base, they cancel out and you're just left with x. Here, you have base b raised to log with the base b. They cancel out. So if your bases are the same, they'll cancel, leaving you just with x. So guys, basically all of these cancel out. It's equal to x. Cancels out, it's equal to x. ln and e cancel out, it's equal to x. All of these are equal to x. Guys, there's no base written right here. What do you imagine is there? Yes. Okay. Same base, x, x. This is the point that we're trying to make here. Okay. All right, so now you're just doing inverses of each other. I will do a few of these with you. Guys, what is the inverse of e to the power of x? I'm looking at number 17. ln x. These you can find algebraically. You can do those. Those are linears. Log base 12, what's the inverse? Yep, 12 to the power of x. So I'll let you guys do these. And that is pretty much the end of our lesson here. Okay, so a great question was asked. Someone asked why, if I have something like this, why does it equal x? Okay, so I'm going to just try to show you guys why through an example. Okay. So let's replace this with a number and let's see if we get the same number. Okay. 2 to the power of 3 is 8. And I know 2 to the power of 3 would give me 8. So that would be the answer to this. So basically those canceled out and I have 3 is equal to 3. So for any of these, if I have a log base 5 of 5 to the x, I can do the same example on all of these. I'll show you that if I do 3 here, okay? All right, let's make it easy. Let's do squared. So this will become log base 5 of 25. And 5 to the power of 2 would give you that 25. So basically those canceled out, leaving me 2 equals 2. Or the general equation, or let me not write it like that. Log base b to the x will always be x, because those cancel each other out.